Hello friends, welcome back to another video on big data analytics. This is your own channel. As such, feel free to like, subscribe or comment on the videos. The topic for today's session is data persistence in Spark. There are two ways in which we can persist data in Spark using the methods persist or cache. Now, you have already learned from previous sessions that Spark is in-memory processing. The RDD which we create, the partitions of the RDD get stored in the memory of the worker nodes. If you have not seen my previous video, then I would suggest before proceeding with this video, you should have a fair understanding of RDD and DataFrame in Spark. Let us get started with creating a RDD and a DataFrame. I would like to show the persist and cache functionalities both with RDD and DataFrame in this session. We will create a Spark session and a Spark context. You know that to create a data frame, we require Spark session, and Spark context is the entry point to create RDD in PySpark. Let us also have this Spark UI interface opened. We will require this Spark UI as we proceed through this part of the session. This is the Spark UI. I'm using Control Tab to switch between my browser tabs. Okay. We will now import two data files. One is MBA students data, where I don't have the headers. The column names are not present. As you know, RDD in Spark does not have column names. So this is the syntax to import data as RDD. The subsequent syntax is to import the data file which has headers. Here I am using infer schema equal to true. So the column data types will be inferred by the function automatically. Let's execute, shift enter. The content of these two data is not important because we are more interested in understanding what happens when we call function like persist. What are the different ways of persisting RDD or data frame in Spark? Let us quickly see our Spark UI once again. Here we need to focus on the executors tab. We have imported two data. One is RDD and other is data frame. It has consumed 103.2 KB out of 366 MB which has been allotted to the Spark session. Let us see the jobs. The jobs that we have executed. So here, this is the last job that we executed, where we imported a file and simply displayed the count of records. So far, we have executed two jobs for importing. So far, we have executed two jobs for importing, one RDD and another for creating a data frame. Let us switch back to our Jupyter notebook. Now I'm going to import one more file which is of stock market data having 3,67,000 odd records, and it is about 16 MB in size. One simple question: how does Spark manage the data frame or the RDD in memory. Spark automatically manages the RDD in memory and removes them from memory as and when required based on least recently used fashion. So automatically the Spark RDDs which are created may be removed from memory. That is all decided by Spark framework. So here, as I execute this syntax, I will be importing a file having 16 MB in size. Before that, once again, it is important for us to see the Spark UI. So let me switch. Let me switch back to the Spark UI interface. Let us see the memory usage. The memory usage as of now is 71 KB. Earlier it was about 102 KB. Now it is reduced to 71 KB. It's okay. Spark is automatically managing the RDD and data frame in memory. Control tab. We are back to our Jupyter notebook. Here we are importing this file. The required packages is coded here. The schema has been declared. This is the syntax to import and repartition the data into 200 partitions based on symbol column. Then we are filtering the data of the stock reliance. This is stock market related data. I am pulling out all records which belong to Reliance stock. Finally, here I am going to print how many records we imported and how many records we have in the filtered data frame. At this point of time, the objective is to see the Spark memory usage. So we are just importing a file which is relatively larger in size. Shift enter, code is executing. It will take some time. Okay, our file has been imported and the number of filtered records is 246. Let us go back to the Spark UI, refresh this page. If you can note, there has been an input of 31.2 MB and the storage memory usage is only 108. What has happened? Let me try to explain you. When we executed this action stockdf.count, the entire lineage which is from the import step got executed. For stockdf.count, let us now check the jobs. This is the job for I think so. This is the job for the stock data. So here we have this entire import. Step 1, 15.6 MB data is imported. 200 out of 200 partitions created, and then finally the count query executed and we got the count. Let us get back to the next job. This is job number 4. This is job number 5. In job number 5, once again we see the entire file scan.csv is imported. The partition filter is applied and then we get the count. What has happened? When you call an action, the entire lineage which is there to create this RDD gets executed. When you called this action, the entire lineage for creating this RDD or this data frame gets executed. And what is the lineage for this data frame? Import. After import, apply the partition. What it means is, whenever you call a action, all the steps gets executed right from the beginning, and this leads to increase in processing time. How can we reduce the processing time? We can reduce the processing time by persisting our data frame. When we persist, we tell Spark, we give a hint to Spark that we are frequently going to make use of this data frame. As such, make a permanent copy of this in memory. Or you can also suggest make a permanent copy of it on hard disk. Both options, memory and hard disk, are available. So let us now try to understand the persist functionality. If I execute this filter df.count once again, what will happen? The entire lineage of transformation will be re-evaluated up to the point of this action, which means the file will be imported, it will be partitioned, after partition filter will be applied, and we'll finally get the count. Do you want to check it? Let us check it once again by going back to our Spark UI. We are in job number 5. This is job ID 5. We will once again run this count functionality. Job 6 will get created. Let us go back to here. F5, refresh. Job 6 is in process. It is not yet completed. Let me F5. It is now completed. Let us check the execution plan. In the execution plan, you can see scan, filter, partition, all steps got re-executed. The input starts from reading this 15.6 MB file, which is on my hard disk. So you can understand that processing time gets increased each time you call an action. The entire lineage gets executed. How do we avoid that? We can avoid that by persisting our data frame. How can we persist? There are two ways of persisting RDD, using persist or cache function. Cache function is same as persist when you use the memory only option. There are many options in persist function. When you use persist function with memory only option, it is equivalent to cache. That is, you are giving hint to Spark that persist the data frame in the executor Java virtual machine on the worker nodes. Besides memory only, there are many other options: disk only, memory and disk, serialization. We will see these options shortly. Let's start with memory only option. By default, from Spark 2.0, the default option of persist is memory and disk. When we say memory and disk, it means that if a data frame or a RDD has to be persisted, Spark will try to persist it in memory. If there is no sufficient memory available, Spark will persist it on hard disk. Okay, how do we persist? For persisting, we require the function storage level, and here I want to persist a data frame, filtered data frame, and I am going to give it a parameter to persist in memory only. Persist is a transformation step, and you know Spark is lazy evaluation. Transformations do not get executed unless an action is called. So we need to invoke an action. What I mean by this, if you have not understood, let's get back to our Spark UI and see the storage tab. It shows no data frame, no RDD is in persist stage. The storage tab of our Spark UI displays all the RDD and data frame that has been persisted. As of now, there is nothing which is persisted despite we having called the persist function. For the data to get persisted, we will have to invoke an action. So I have to call this count function. It is going to take some time as persistence of the data frame will happen. Okay, the data is now persisted. Let's go back and see the storage tab, F5. The entire cryptic name for that RDD is coming here, so don't bother about it. Memory serialized, 1x replicated. 1x replicated means one copy of that object in memory in serialized form has been created. There are 200 partitions. As you know, we had repartition syntax and we suggested 200 partitions be created. So 200 partitions. Because the data is stored in serialized format, it is taking very little amount of memory and the size consumption is just 13 KB. The size consumption is just 13 KB. Now coming back to Jupyter Notebook. If you are getting confused between my toggling, don't get confused. Let me show you. The two tabs are here. This is my Jupyter Notebook tab and this is my Spark UI tab. I am just using Control tab to toggle between these. For some time, I'll use the mouse cursor. Okay. Now I execute the count function once again. And this time I'm going to execute the count and let's see how fast the output gets displayed on the screen. Shift enter. The data is now coming from persisted data frame. It was relatively fast compared to the previous steps. This is because we got the count from a persisted data frame. How do I prove that it has come from persisted data frame? We have to go back to Spark UI jobs. The last call of this job, we have to see the DAG, and this time around when we see the DAG, you can see the scan steps. It is taking the data from in-memory table scan. The partition which was created in memory, the output we are getting from that place. Certain stage has been skipped, which is reflected here. So when we persist a data frame, the data frame gets created in memory and the processing time is relatively reduced. Okay, let us now see cache. Cache function is very much same as persist, memory only. When we call a persist function with memory only option, it is equivalent to calling the cache function. This time I'll show the cache function on RDD. We had imported the students RDD data. This is the step if you have forgotten. Here we had imported and created the students RDD. It is an RDD, it is not a data frame. With RDD, you have a function called setName. So I'm just giving some logical name and I'm calling the cache function and a count function because an action is required. Having called the count, let us now see the storage. If you see the storage, a logical name for our data set comes here. The set name functionality is not there for data frame. As such, I could not give the set name and we have this longish kind of name appearing. Moreover, the output you can see, the cache is also giving you memory serialized 1x replicated, very similar to what we had for the filtered DF memory serialized 1x replicated. Okay. What are the different storage level? We already saw there are different levels of storage. We can have memory only, disk only, memory only and disk only. These are very self-explanatory. Memory and disk, this is the default storage since Spark 2.0. Then we have memory only SER. Memory and disk SER. SER stands for serialized. These options are valid for Java and Scala. In PySpark, by default, persistence of data happens in serialized format, which you have already seen by the term memory serialized. There are various levels of these storage, and these levels are actually provided in the function storage level. Shift tab to see the documentation help, and here let us see the documentation. The parameters are use disk, use memory, use off heap, deserialized, replication. By default, the serialization and persistence is on for memory disk. So the first parameter by default is true. Second parameter by default is also true. Deserialized in PySpark, by default, persistence happens in serialized format. So the default config is false. Use of off-heap memory is also false. And the replication factor is 1. The entire details is all given here, which you can note. So I can do persistence using this storage level function also. If I say storage level equal to storage level true, true, false, false, true, this syntax is very much equivalent to running this syntax. So students data frame 1 persist storage level memory and disk 2. What is this 2 here? The numeric value 2 here is suggesting that I want a replication factor of 2, which means 2 copy of this object should be created in memory of the worker nodes. I am running the code on laptop. There is only one executor node. There is only one worker node. As such, creating a replication of two is of no meaning. The replication factor of 2 should be used only when you want a higher level of fault tolerance and when you are running Spark in a cluster mode. And typically we run Spark in a cluster mode only. Here for the training purpose, I'm running it on a personal laptop. With the replication factor of 2, you get additional fault tolerance. If a worker node is dead, which has a persisted data frame, another worker node having a copy of it will come into action. So we can use a replication of 2 also. How do I know what are the various options? What I can do is I can delete this, and after dot I just press tab. All the options are available. So here I select this option. This option, memory and disk. Disk is the first parameter, true. Memory is the second parameter, true. 2 is this parameter, replication. If you see the documentation of storage level, you will get to know this. Use disk, use memory, off heap, deserialized, replication. We can set the value of replication either 1 or 2. Okay. Let me comment this again and execute this persistence code. How do I check? Obviously, I have to go back to my storage, refresh, and here you can see 2x replication, and here you can see disk and memory serialized. Okay, let us switch back to our Jupyter notebook. We can check the storage level attributes. Let us run the storage level for RDD1. You can see the used disk is false, memory is true, replication factor is 1. Let us see the storage for data frame, students data frame 1. And here you can see disk and memory is true. Let us check the storage level for filtered data frame. Note the function here for RDD we have function get storage level. For data frame we have attribute storage level. These are small differences between RDD and data frame. We can note here this is memory and replication factor 1. What is 1x, 2x replication? I have already discussed. 1x means 1 copy in persistence form is created. 2x, 2 copy are created, and 2x should be used when we want additional safety, additional fault tolerance for our RDD or the data frame. How do we remove RDD from a persisted state? Use the function unpersist. I'll unpersist data frame 1, shift enter. Check the Spark UI, refresh. One of the data frame has gone from the persisted stage. Shift enter, shift enter. I have unpersisted the data frame and RDD. Let me refresh here. There is no object in storage. What will happen if an action is invoked on an RDD that has been unpersisted, or a what will happen if an action is invoked on a RDD that has been unpersisted or which has been automatically removed based on least recently used fashion? If you run an action, the entire lineage will get executed. For example, once again, I'll write the syntax for filtered df.count. Filtered df.count, we import stock market data, we repartition it, we apply a filter, and finally get the count. These are the steps which has to get executed. Shift enter. It is now taking time because all these steps has to get executed. Let us see the jobs, and here if we now check, there is no stage which has been skipped. The entire data has been re-imported. The import stage has been executed. There is no step which has been skipped. When should you use persistence? The key question is, when do I use the persist functionality? We should use the persist functionality only if the number of transformations that are applied on data are large, they are time consuming, and reprocessing the data is a huge processing time. We should use the persist functionality when the processing time taken to create the RDD is large. When the number of transformation that you have to apply on the data frame is large to create the RDD, in that case you should use persist. In above example, I have simply applied one filter. Application of one filter frankly does not justify the usage of persist. I have used this example only to demonstrate persist, unpersist, cache, storage level. If you would have noted, the time taken to get the count from a persisted data was fairly same as the time taken to re-evaluate the entire process, because there is some time which is spent in deserializing the data frame or the RDD. If the number of processes I would have applied are many, in that case persist would have been of more benefit. In summary, persistence should be used when your data frame is large in size and when the time taken to process it is huge. As a small exercise, I would want you to try persisting a data frame and a RDD to disk only. For any big data analytics corporate or individual training requirement, feel free to connect with me on my email or WhatsApp me on my mobile. Check out my blogs where I have written lots of articles on machine learning algorithms. With this, I end the session. And remember, this is your own channel on big data analytics. Feel free to share with your friends and colleagues. If you have benefited if you have benefited from these videos, then why not subscribe and like the channel. Thank you.